rotary pump, you can use this another roots blower, which was popularly given by Roots for making a silencer, by making a sirens, etc. He has never thought that he is going to be a pump. After his death, after 40, 50 years, it became a pump. Okay, this discoveries happen like that. Similarly, Boolean, he has 400 years back, he thought that if there are people with 2 fingers, how they count. He made some crazy algebra, no mathematics department took it for 100 years. But today, Boolean algebra is the main algebra. So that's how things happen. So all I want you to understand is, try to be fundamental, otherwise you will become mental. Okay. So try to use this little bit of maths, little bit of physics, little bit of chemistry, material science, mechanical, electrical, civil, and computer science, and programming, and finally management. If you do that, something about everything and everything about something is the truth. That is the story. If you know only everything about something, if that is not required by others, you are jobless. Be careful. So next pump is, time is over, I think. Or maybe, I think he is, I wish he sleeps so that he will not come. Sir, take rest. Okay. These are my stators, these are my rotors. And turbomolecular, where is that person? I have forgotten. I told I will take your help. Where is that Pfeiffer Admi? Please bring your turbomolecular. Open it while parallel. Take your own time, no tension. This is the pump. If you are going to be in business of semiconductor, you will have to use that pump. Such a small pump, and it is costing 20 lakhs. Whereas such a big rotary pump, it is removing 99.99% of the air, it is 12,000 rupees. So fellow who removed 99.99%, its cost is only 20,000 rupees. The fellow who removes that 0.01 to enter into metallurgy, to enter into space technology, nuclear, electronics, that person, he is able to handle it like this, and it costs, and careful, because I have broken hand once, that's a problem. And now, this is my, good. Okay, so this turbomolecular pump, so costly. Why? Because they made it smaller and smaller, faster and faster. The fan here, put it this way. Array, I asked you to open it, everything. No, you did not open? No. Oh, it was, you did not have the tool to open?
Yes, yes.
Oh, I know. So that's why troubleshooting is the most important thing. Later you will see, those who are matter, those who think their lifeline is related to that, spend after 5:30 when nobody is there, he will be there to open this and show. He is going to open. Okay, this is the suction which is connected to the rotary pump. There is a high speed turbine with a magnetic bearing, thanks to the research scholars who have made that bearing. Okay, and it rotates at 1 lakh revolution per minute. Olden days 1 lakh means 10 kilohertz. 10 kilohertz only in oscilloscopes we will see for electrons. Most of the fans and all, they move 1000 RPM. I am talking 1 lakh RPM. So the technology has gone up. Last 40, 50 years only. Earlier nothing was there. Earlier molecular structurology, molecular biology, all these words are not there. Now molecular things have come because of molecular pumps, all this, because of last 70, 80 years only. Before that, no electronics, no computer science. Okay. So, okay. So that's how the turbomolecular pump. The idea is, if here is a moving wall, suppose I am coming like this, I hit somebody, some ball is hit like this, it will go exactly opposite. So sin I is equal to sin R, oh, that all now we know in 9th class. But when it is hitting, the wall itself is moving. Suppose this is also moving, and I am going like this, there is additional velocity imparted to me in addition to my random velocity in a particular direction. That is called directed velocity. Who knows this directed velocity and random velocity? The best person who knows this is the fellow who created pressure energy, velocity energy. What is his name? In aerospace principles, etc. Pressure is low, voltage velocity will be high. Very good. Bernoulli's theorem. So Bernoulli's theorem says that pressure and velocity are related. Here the random velocity, which is 330 meters per second, is pressure, because pressure only. P is equal to 1/3 mnc square. I use that velocity to make it pressure. But if I put a switch on the fan, only 10 meters per second. Even the gale storms, how much? Some 100 meters per second type thing. That 10 meters per second will create lot of wind and hurry comfort, all that and all. Whereas 330 meters per second these molecules are moving and nobody bothers about it. I cannot feel the pressure of it. No pressure also is not there. Whereas 10 meters per second velocity, little bit of wind creates a lot of comfort, because this is called velocity. That is not called velocity, that is called random velocity. Random velocity is called pressure. This he understood. That's why he created the aeroplane. The 4 forces, no? Thrust, drag, lift and gravity. So 2 equal and opposite forces, 2 equal and 4 forces equated it. He said 10 kilometers height, these things will matter. You will have a slew rate of 500 kilometers per hour speed, it will come. If you go to 20 kilometers, you will not have air. So the Bernoulli principle will not work. The wings cannot create higher pressure and lift cannot be there. So it will again come to 10 kilometers. If you go to 3 kilometers, then huge what you call drag will be there. Thrust is not good enough. This much few liters per type of fuel is not good enough. It will go in 100 kilometers like our vehicle. So only at 10 kilometers height, these things matter. The gravity is exactly matched by the lift created by both the wings, because of the compression created by the eddies, created by stopping of the air below the things. That created lift. And exactly at that time, whatever thrust created by the fuel is equivalent to the drag by the air molecules. So these 4 things, the same design has to be there in turbomolecular pump. That is where they created this high speed turbine. The turbines of the turbojet engine are very high speed. So that after that discovery, then the semiconductor people thought that one day he has gone abroad on a special duty, and he was using in India some 10 power minus 7 torr semiconductor and all. These things are highly rotating, why can't we make this in a pump? So this Pfeiffer company, they have done it. There was Becker, who was the inventor of turbomolecular pump. He thought that if the tip velocity R omega of a high speed turbine, if it is same as 330 meters per second, then my velocity of a solid body is of the order of the molecule. So I can drag. If my speed is so small, if your speed is very high, I cannot give you additional velocity. So very high speed velocity can impart an additional component to that in a molecule wise. When it will happen, if that fellow also moves like a molecule. If it is a gas, I cannot give. In fact, gas will break it, because it has got a small motor, itna gas. Even with this so much of 200 kilo, with such a big motors, it is only operating, rotating at maybe 500 RPM. And I have to make it into 1 lakh RPM. So I should already have a vacuum, not to have any drag. At that conditions, each molecule is behaving like a molecule, no more gas. Now I can give, because I am moving at a high speed, solid is also not a gas, and you are also not a gas. So molecule, you are a small molecule, I am a big fellow. I am like a striker, you are like a coil. I will give huge momentum to it, and that momentum falls from down. And as soon as it comes here, there is an automatic opposite bent turbine. That turbine, what it does is static. So it reorients and converts that into pressure. Whenever when it lands, the phone lands, what will happen? Immediately they start opening. A huge drag will be there to stop the plane. Otherwise it will keep on going, crossing the airport at that speed. Is it not? Same thing here. Such a high velocity if you create 10 power minus 8 torr, and you have to convert into minus 7 torr first by compression, small compression. It's not like a huge compression of a rotary pump. That fellow takes 10 power minus 2 torr, creates to 10 power plus 3 torr. So 10 to the power of 1 lakh is the compression ratio, and it's only 10,000 rupees. Here is only 10 compression ratio, it is 20 lakh rupees. But it is compressing molecules. Okay? So it is a molecular pump, turbo molecular pump. So this is again converted into pressure, and next turbine is again rotating. So alternative stages of high speed rotor and a stator will create velocity, pressure, like that, step by step you increase pressure. Finally you come to a minus 1 torr. At minus 1 torr, continuity principle works. It behaves like a gas. Same molecules earlier rotary pump could not pump. Now these fellows say, some fellow has made all of you to compress to minus 1, now I will pump. So this fellow rotary pump is backing this turbomolecular pump, to remove those gas molecules which it could not remove earlier, because they were behaving like molecules. Their fellow says, wow, how do I care whether you are rotating or not? I will not come to you, pump. There is no tendency of the molecules to go to the pump in a molecular flow. But in a molecular flow, the turbines are also rotating at molecular speed. Then by chance, if I come there, immediately I will go. So here the pumping speed of this turbomolecular pump, which he has shown, does not depend on any of the things that are going on. First, things have to come here. If you have to come to the IISc, then I can teach. If you don't come, you don't cross the gate, how can I? Even if I teach, you cannot listen. Of course, nowadays you can listen from anywhere, but it is different here. But there is nothing like direct listening. So molecules have to come first, then only this fellow can pump. And so that means any number of molecules you come, I can pump, but you have to come first. So the pumping speed is controlled by not the mechanism of the pump. It is controlled by the arrival probability of the molecular velocity, kinetic theory of gases, Monte Carlo techniques, how much molecules are coming, thermal velocity, all that lot of modeling is there. Several PhDs are coming even now. Okay. So this is how people calculate with lakhs of directions you have to show, put it into the computer, and then see net flux, how it is coming, etc. And then it is not because of P2 minus P1. P2 minus P1 is not creating the force. Normally at higher pressures, P2 minus P1 is the driving force. Here it is the concentration difference from the molecules which are there inside, they will also go back. Lot of molecules are going from pumps to chamber. From chamber to pump also it is coming. But chamber is minus 7 tar, pump is minus 8 tar. On a net equilibrium, statistical modeling, if you do minus 7 tar, the X molecules come in the X direction in the 360 towards the pump. 0.9 X only come this side, because molecule is less. So there is a net probability in the pump. So this is how turbomolecular pump mechanism itself is different. If you understand all these things, why should you understand? Nothing wrong in understanding. If you don't want to understand, where you stand? For everything you import. Okay, if you want to make, the moment you make this turbomolecular pump and make it 5 lakhs instead of 15 lakhs, he may not be happy, but many people will be happy, okay, because huge sources are there. So semiconductor manufacturing is not making semiconductor alone, semiconductor ecosystem, the oils, the turbines, the blades, materials, silicon, crystals, pumps, compressors, water, deionized water, electrical connections, safety mechanisms, new insulators, all those things are part of the game. That is 90% of the money goes. In fact, 50% of the money in the ultra high vacuum thin film coating units for used for semiconductor goes in vacuum chamber only. Why it is so costly? 86,000 crores given by the Prime Minister of India. Why? Out of that 46,000 crores will go in vacuum technology. Because chambers have to be so pure, clean, and another 10,000 crores will be civil engineering structures, because making clean rooms. So much clean, green need not be there here, semiconductor, clean. Then you will start behaving in a molecular control. Unless you control molecularly, ppm has no meaning. See, the value of ppm, our PM knows. That's why he is giving lot of importance to the semiconductor manufacturing. Anyway, so this is how you have understood some production, and pumping speeds are independent of pressure, because any number of molecules I can catch, minus 8 or minus 9, whereas rotary pump fell because of compression expansion principle. Here no compression expansion principle. Any number if it comes, I will pump. If less only will come, the higher the vacuum, less only will come, I can easily pump them. Or if I can teach 200 people, 20 people, nothing. Like that confidence develops. Okay. Same thing, but it is not. You don't get 10 power minus 20 tar. Why? Because you are pumping, but I will leak. Even if few parts, some 1 gram of vapor, air leaks into that per unit time, it creates huge burst of minus 7 tar. Whereas same 1 gram of air leaks at minus 2 tar, it 2 into minus 2 tar to 3 into minus 2 tar. Same number of molecules, some 10 lakh molecules have leaked in per second. 10 power minus 2 tar has become 5 into minus 2 tar. Whereas 1 into minus 7 tar, same 10 lakh molecules entered, it became 1 into minus 1 tar. 6 orders it has raised. Because at that level, unit volume requires only that many molecules, because that is the pressure. P is equal to NKT. P is equal to 1/3 mNc square bar. The number density required to spoil the vacuum is very small. That's why fine leaks have to be taken into account. That's called troubleshooting of vacuum systems. That is the last thing I wanted to cover. So this is another pump on the way we can discuss. This is called cryo pump. If you don't want to pump by giving all these mechanisms, if I can condense all these molecules into liquid air, there is nothing like that. Like I just know before khana, I took heavy khana, I thought there will be degassing problem. What I did, one aluminum hydroxide diazine I took, it absorbed. And I have no problem for 1 hour. So I can teach. Same thing here. Here we try to keep some absorbing molecules and cool it. On cold condition, molecules are coming from other here and there, air molecule, nitrogen molecule, oxygen molecule, all of them will come after created by 10 power minus 2 tar by the 10,000 rupee rotary pump. Now cryo pump is on. So molecules will come to them, and this is so minus 200 degrees centigrade. It will condense like ice, and hydrogen cannot condense even at that. It will go into that charcoal, which is having millions of square kilometers area. Apparent area is only square meters. That's called porous materials. Atoms know how to go into that, like charcoal which you are using. Why it is absorbing so much? Because its apparent area. Oh, this is exhausted. This gets exhausted. Nothing. So sometimes without microphone, voice will look like noise. Otherwise, it will look like noise. And there is no charge. I hope this works. Very good. And if I have one tie also here and mic, then Mike Tyson. Deep mining. So this I leave it to you, and quickly I want to measure the pressure. It's my pleasure. Bourdon gauge, all of you know, this is available in your gas cylinders. I think mechanical engineers, how many mechanical engineers are here? Oh, lot, very good. So in your college you do it, and even electrical engineers are mechanical. First year mechanics pada na? That is called mechanical, nothing more. I am physicist. If I can land, you can easily land. Okay. So Bourdon gauge is nothing but vacuum is connected here. Outside is atmosphere, and when it is taken, it is a C type of structure, C language. Okay. Exactly same symbol. And inside is vacuum, outside is atmosphere. Then what will happen? There will be net force. The C will curl in. When C will curl in with this mechanism, it will go up and down. and you put one sticker to this, and you can make it at home. But that will be only 500 rupees. So let us spend 50,000. What? How does it matter? There is a project. 2 mics. Oh, great. Okay, so pointer linkage and all these are all possible. You can convert any of the existing gauges and do some repair. Why should you repair unnecessarily? Nowadays software is best. Okay, so this is the first gauge. Second gauge, where is my friend from Horiba? Where is he? Somewhere. He has left things here and then I represent. Okay, this is a capacitance gauge, ideally used in semiconductor manufacturing. Now earlier we used to have a meter, etc. Now they convert into computer. This converted into A to D converter signals and flip-flops, all that is included inside. Switching devices, safety devices, constant temperature making, all the corrections you make it. More and more soft class styles you incorporate, it will look very nice. But if you want, you can also make all that. It depends on error, how much error you can afford to have. And if you don't want online, you can make it a simple microvoltmeter available in the outside market. You can connect it. That voltage is proportional to current, and lower the voltages, voltmeter is costly. Lower the currents, current meters are cheap. A milliammeter will cost 100 rupees. A microvoltmeter will cost 1 lakh rupee. Higher the voltages, reverse. Okay, high currents are difficult to measure. You use standard that inductance type of meter, and because high currents are very dangerous to put meters and all. High voltages, only high voltage, that R, B, Z, they are all maximum 500 rupees. Higher the voltage, currents are costlier measurements. Lower the voltages, voltages are costlier. So most of the Pirani gauges, capacitance gauges, what do? They convert that voltage into current finally, and current meters are cheap. This is the instrumentation fundamentals, basic electronics. So first you should have a transducer which is sensitive to the pressure variation, convert into electrical signal. If you are tired of electrical signals, you can even make it frequency signal, because frequency can be measured very accurately being 1 by 2 pi root LC, 12th class we have studied now. So frequency can be measured in 1 in 10 power 9, whereas voltages cannot be measured in 1 in 10 power 9. So capacitance, what they do, there is a diaphragm, metallic diaphragm, there is an electrode, and the gap between this one epsilon naught A by D, this is the capacitor. This is insulated so that this is not short circuited with the body. This is the gauge. This is connected to the chamber to be measured, vacuum. Now as the vacuum is developed here, this is closed, and getter small pump is used as a chemical absorber to take care of any leaks here, so that it is always maintained at 10 power minus 7 torr. Half of the chamber is minus 7 torr. This is connected to the chamber. When this comes higher pressure, it will be always higher than this, so it will deflect. When it deflects, what will happen? Gap decreases, then capacitance changes. That 1 by 2 pi root LC, F changes. F can be very sensitive. You put a lock-in amplifier, you will get very sensitive detector. So frequencies can be measured very accurately. That's why you have got 10-digit numbers cell phones now, because 10 gigahertz type thing you can give one frequency to you, one frequency to you. If you have to give voltages to everybody, it is really difficult, isn't it? 1.1 volt, 1.2 volt, I cannot make it like that. Maybe qubits, when they come later, it may change. But right now, it is all in the frequency domain. Okay, every fellow has got one frequency. So same thing here. From there you measure. This is the most accurate gauge. Why I am using? Because Pirani gauge measures in 1000% error, no point. This is very accurate. It is independent of the nature of the gas. Even if some petroleum gas comes also, nothing will happen. The electronics will not get disturbed. The sensor will not get disturbed. But if you suddenly open a Pirani gauge when it is hot wire and it gets cut, then who will go? You will throw it. Whereas this fellow will never get. It is a highly rugged gauge, and it is a reproducible gauge. Okay, depending on the thickness, you can make it 10 to 100 torr one gauge, 1 to 10 torr another gauge, like that. They manufacture all these things. And in semiconductor, you require flow of that gas, this gas, etc. After getting 10 power minus 8 torr background vacuum, you spoil it to minus 4. But this is not spoiling, it is doping. Spoiling is oxygen, nitrogen, doping. So those gases, it is a flow meter. This is again simple principle only, but it requires little explanation. So this type of flow Otherwise, so like that various gases will go in after getting a background vacuum. Sir, why should I get -8 tar with costly pumps and then make it -3? You have to do it. If you don't make it -8 tar, initially lot of air is there, they will be already, you don't have to dope it again. Already it is doped and spoiled. Is it not? So you never heat the semiconductors and never process start unless you get a background clean vacuum. Clean with respect to contamination. 10 power minus 4 tar clean from oxygen is much better vacuum, 10 power minus 8 tar full of oxygen. Even if you have 10 power minus 5 tar, if you are sure it is a leak tight system, it contains only argon or helium or anything, inert gases, then you will get pure semiconductor. So it is not only the quality of the vacuum, it's quantity of the vacuum, quality of the vacuum is important. Okay. It is not just -8 tar we want for the sake of it. Even in -8 tar to another 10 lakh molecules are there at cubic centimeter, we know that. But it is not that botheration for us. But we don't want huge trillions of foreign molecules, billions we can understand. Billions is the background vacuum. Don't think that you have purified to 0 level. Okay, so with these measurements also we have done, production principles we have done, and then other gauges I leave it to you. Penning gauge, Pirani. There are only 2 gauges, Pirani, PP. Both the gauges in India, they measure, but measure, that's all. You don't take it into account for calculations, anything. It's okay. That even without measurement also you think that no sound, so vacuum must have been good. It is equivalently good gauge. So that's how it happens. So pressure measurements, displays are very good. Today we have seen a lot of display looking very nice, but the transducer is bad. Transducer measures as 100 millitar and 100 gives perfectly like 100 there. So I can only create gain factor adjustment, electronically I can do. But the actual physics measurement, if it is poor, no point in that. So it is the sensor that is more important than the display. Yesterday semiconductor, today morning display, now I am telling sensor. Okay, starts with sensor, senses, and then go to the display, and then only you will get semiconductor. Okay. So Penning gauge is like a principle. Penning has done lot of work. He throughout 40 years he worked only one gauge. We do lot of research. Sometimes physics, sometimes chemistry, sometimes mathematics, sometimes programming, sometimes management. And after BTech you go to MBA, then BA, anything, whatever you do. No, unrelatedly we can do many things. But Penning has not done. 40 years he had done only Penning gauge, Penning gauge, Penning gauge. Pirani, only Pirani, Pirani throughout 40 years. So he made that Penning gauge. What he thought was by the time field emission spectroscopy came, so people can emit some electrons, not by thermionic emission, emit the electrons from a body by putting a high voltage. That is also used in microscopies. You know, what is that? Scanning probe microscope. So voltage you apply, the Fermi, whatever is the topmost atoms, those electrons can come out if their work function is overcome by that. These electrons when they come, they are very few, and if you are with those few electrons you want to ionize them. If you can ionize them, number of ions produced is proportional to number of molecules is proportional to pressure, you have got a pressure gauge. But how do you ionize them? First, these are only few electrons. These electrons have to be amplified, electrons have to be accelerated so that they will have enough energy to ionize the atoms to create a plasma. And they how to do that? You can accelerate by electric fields by high voltage, 3 kilovolts. In a Penning gauge you have 3 kilovolts. That, and you have an applied magnetic field. Magnetic field does not do any acceleration. It will only confuse the electrons. Charged particles can only will not cross the magnetic flux lines. So they will keep on rotating. In the process, their length has increased. So their chance of coming across the atoms whose density we want to measure related to pressure, that is more now. Collision cross section is more. Then immediately you will start getting ionization. These ions will be collected by the anode. That anode current, if you measure, that is a measure of pressure by suitable calibration. This is how ionization gauges are measured down to 10 power minus 8 tar. Nothing is perfect because it so happened it is calibrated. If you say 10 power minus 4 tar, I can tell you are wrong, you cannot say anything. So I don't know, it is -3 also, it can be -1 also. So, do not be surprised to get surprising results, and because your measurement is wrong. So, measurement has to be equally good. There is a very good measurement person can get much higher salary than the production man. That is called quality control. So, this is how either you measure heat transfer and related to the number density, that is called Pirani gas, or measure the ionization and related to the atomic density, that is called ionization gas. Both these gases if you complete, then what is left over is very important. I have 10 minutes or 15 minutes or any amount of time till the last person leaves. 15 minutes. Okay. Now, this is a very important thing is 15 minutes definitely I will cut. 10 minutes में आप थोड़ा you have bell like this. Okay. Flow is very important. One fellow like you, very intelligent person, what he did was he purchased 300 liters turbomolecular pump, spending 20 lakh rupees. The people were very happy. The company people also gave him very good treat, and they were very friendly. He was trained in the foreign that he came all the way. And it is a very big pump. Another 20,000, 1 lakh rupee chamber is created with semiconductor and nice looking rooms, everything. He connected this pump with that chamber by a long pipe, and that pipe is only 200 rupees. Okay, and he purchased it from market naturally, because he will not purchase tube also from the abroad, is it not? That you cannot make tube also here. Then what will you do? At least pipe, rubber pipe you purchase from here. So okay, indigenous. So we made the things. This 300 liters per second, we thought and calculated with this much VdP by dt, all that calculations, mathematics, computer programming, everything. He is supposed to get in 1 hour 20 minutes, 10 power minus 8 hour. If everything goes well, hoping it's very nice, like in chambers where they are manufactured in France and Taiwan, chambers also will be good, everything will be good. Only the interconnecting pipe we have made, and this fellow with 400 liters per second has become 4 liters per second. And I can exactly show that. Right now, you bring your turbomolecular pump in this building, CeNSE building, NanoScience building, connect it here. You bring any chamber of your like, you connect it straight, you will get in 1 hour. You connect it in a long pipe, you will get it in 20 hours. And within 4 hours, you are supposed to do. So what he will do? It is taking 10 days time. It is better I re-employ some fellow, please out. Because you are 24 days for evacuating to 10 power minus 6 star. When will you make the P-type impurity, N-type impurity? When one device, I want 1 lakh devices per day. This is nonsense. You don't know anything, get out. So this is how problem came. So the conductance is like, you have a 1000-volt battery and you have another motor, but you connect it with a wooden scale. You cannot get current, is it not? Pressure, voltage drop. Similarly here, pressure drop. This is called Ohm's law of vacuum technology. Pressure drop is equivalent to voltage drop. The mass flow rate is equivalent to current. The ratio is resistance. That is called flow resistance, that is called electrical resistance. So that is the flow of the gases through a pipe. At high pressures from atmosphere to 1 tar, you have a viscous flow. Mechanical engineers know very well, turbulent flow and laminar flow. When the flow is moving like a laminar with a velocity gradient in a parabolic type, that is called laminar flow. That happens in a Reynolds pen, Reynolds fellow. This fellow is a very great fellow. He tried thousands of pipes and hundreds of diameters, kept on changing. He was not knowing any mass physics chemistry. Reynolds, you know all of you. If mechanical engineers definitely know Reynolds number. Reynolds number is the basis of convective heat transfer, entire mechanical engineering. Okay. This Reynolds, what he did was hundreds of pipes with hundreds of diameter, hundreds of lengths, hundreds of materials he tried. And for the same flow rate, pressure drops he created. He measured. He made some Reynolds number up to this number is called turbulent flow, this is called laminar flow. And it is valid irrespective of that if you know the L by D ratios. And he made that, and on his name a Reynolds number came. Then some fellow said link it to the thermal heat transfer, then that's called Prandtl. The fellow said Prandtl came. So something on Reynolds number and something on Prandtl number, both you add it, you will get Nusselt number. So all three are scientists, and these three scientists have created B.Tech mechanical, M.Tech mechanical, PhD mechanical. Okay? And this is calculated by mathematicians and physicists called Navier and Stokes, and whose equations are not even solved analytically even now. Okay? Empirically it is solved. That level, if you want to do that, you require quantum computers, and that requires high level of semiconductor manufacturing. That requires high vacuum technology. I can tell like that. Anything can be related to anything. Okay. So, this laminar and flow. This is molecular flow. What happens is at 10 power minus 5 torr, which is the starting point of our semiconductor. We are nowhere here. This viscous flow, as atmosphere to vacuum improves, flow is changing from turbulent to laminar to this. Laminar, each molecule is flowing, and it may go back against the pressure. This may be pump, this side is my chamber, but molecule is not going from chamber to molecule. We thought it will go like that, but it will hit, and the roughness of this fellow is micron. 1 micron is 10,000 angstroms. Molecular diameter is 5 angstroms. So, 5 angstrom fellow will go there, it is like a big hill, and it went like this and came back. It is supposed to go to the vacuum pump side. In viscous flow it happens because molecules are dragging, they do not care about the roughness of the pipe. Okay. Only prayer drop is related to roughness and all, that is standard laws are there, no, Hazen-Poiseuille's law, etc. That is different. But here unpredictable behavior. Molecule goes towards the pump, it wants to go, but it came back. So, how many lakhs of molecules are coming back and front and going on? Who cases? This is a statistical probability. This is called molecular flow. So, this, if you connect a small pipe, it will hit more and more, because my mean free path with respect to another molecule, so that he will at least drag me, is kilometers, and your diameter is only 1 centimeter. I will hit you only. I will not hit another friend. So, no molecule hits another molecule. Every molecule will hit the body. In our case, it is a connecting body, that is called pipe. Chamber is a big thing. Pump is a good thing. Pump is a dynamic rotation. Pipe is not rotating. So, pump knows how to remove molecules. Chamber knows how to send molecules, but pipe says nothing doing. So, it stops. So, pump is running, chamber is there, everybody is waiting, boss is phoning, no vacuum, nothing starts. You have to be careful about conductance calculations. If you calculate properly, you will get several possibilities, like 20 liters per second pumping, that is called conductance. You can calculate, there are formulas I gave. This is little involved topic. This is called fluid mechanics, molecular dynamics in a vacuum system. On some other day, even in college or if online, I can give some 2 hours seminar, that is not a problem. Anytime you can, and you can set up all these experiments. Why I am telling all these things are, you are mostly teachers and students. If it is only industry people, I would have talked in a different language. Okay. So, you use these physical parameters and it will come to 0 pumping speed, effective pumping speed. Manufacturer has given 200 liters pumping speed. It has come down to 0 because that conductance of that calculated from the geometry of that is giving such a low pumping speed unit is same as conductance unit, because here I told you in the first itself, the mass flow rate is not density multiplied by volume, pressure multiplied by volume. So, P is torr, dV is liter per second, torr liter per second. So, if you divide it by P2 minus P1 unit is also same as P unit. So, VdP by dt by P2 minus P1, that is called dP by, the only liters per second. That is unit is matched, 5 minutes then. Okay. So, if you do all that, you have to design properly. If you do not design, you have to resign. So, what are the design concepts? Pump selection, process related things, instrumentation, actuators, leak rate measurements, sealed services, material selection, speed matching to the conductance calculations, chamber design, and if you do all that, robotics and other things and high style matters later, that and all later. So, if you do all that, then you will get only one problem, that is called leak, and leak has to be solved in a particular chamber like this, having thousands of components. This is how the typical UHV system in a your display unit systems or anything will look like this only. So, there are lots of components, all are vacuum components. This is a chamber, vacuum chamber and vacuum components. Anywhere there is a leak. If there is a leak, you have to use one mass spectrometric leak detector and spray some helium gas, connect it and measure the leak detection. So, that I leave it to you. I have got the element, but you go through on your own. Leak detection, this is a very important principle. So, your typical unit will look like this. load lock chamber, wafer will go here, it will go the transfer, it will go to either lithography or analytics or instrumentation or structural analysis or ion beam etching. Like that it will decide. It is like a pentagon chamber. All those chambers will look like a nice thing in a module. That's called tool, whether it is ion beam tool or any other tool. That and all, I just want to get a feel of it. That's the idea I am telling you. Anyway, you know semiconductor fees better than me. So this is how the leak rates are there. Whenever there is a leak, it keeps on a small volume bulb, no problem, or you can throw it. But if it is ultra high vacuum, you same leak, small size hole. If chamber is bigger, pressure rise rate will be small. Okay, such a big 1 lakh rupee salary, 1 paise daily goes, you don't bother about it. But your salary is 10 rupees and 10 paise is going, you have to bother. So where is it tolerable or not tolerable, you have to decide. Once you decide, you measure the pressure, another 2 minutes. So you have to do it with a leak detection. You spray some test gas onto the vacuum. This is called semiconductor manufacturing system. Through the leak detector, it has got its own vacuum pump again, and with that it will give a signal, and with that you can measure all the fine leaks. And you have to start making the leak check from the bottom. If you do that, gas will go top. There it is leaking, but you thought here it is leaking and try to solve it and create a trouble. So better leak check from the top to bottom, not from the bottom to top. Never do that. Okay, because light gas, helium gas will go up and go through that. You get zai sound will come, alarm, immediately stop, close everything, and 5 days, and you create a leak actually, because there is no leak there. You have created a leak that because you have started unnecessarily leak checking from the hunting should not be done. Worst possible portion you should leak first, check. If you do all that, and residual gas analysis also you should do, so that chemistry of the gas, whether 10 power minus 8 is hydrogen or helium, or if that itself has got phosphorus or something, you don't have to purchase phosphorus cylinder. Anyway phosphorus is there, it will dope. So you will have to know the chemistry, that's called residual gas analysis. If you do all that, then vacuum technology will give you a semiconductor chip properly, with then only you will get a cell phone or TV or anything. So all the chambers, whether it is PVD or etching or cleaning or diffusion or ion implantation or chemical mechanical planarization, all of them are coming and going from the masking and lithography. This fellow is central fellow. To this fellow, the wafer will go. So all these mechanisms are vacuum leak tight. When you do all that, you will get chemistry, physics, mechanical, electrical, electronics properly. Then only if vacuum works, chip works, then only you will have these 3 devices. That's how I end this lecture, and thank you very much. And I have given one NPTEL program, Swayam NPTEL 60 hours on vacuum. You can go through this. This is given there. You just you can go through step by step. If you have any doubts, you can ask me later. Sorry, I have taken a lot more time, but thank you.
So, Professor Rao, thank you for nothing.
Thank you. Thank you very much.
Okay, cheers.
I can maybe we can have the.
Come.
My boss will ask me whether it's gone here or not. Because we have active.
Cheers.
Thank you.
Okay, we are at the last stage of the workshop. Normally we would have taken a tea break by now. My proposal is give me 15 minutes. I'll finish this, then we can just go for a tea break, networking, and wrap up. Okay. So since everybody is already in it, you're already in that relaxed mood. Okay, I must get you back onto this part. And this is actually taking off what Professor Rao sir has talked of. I'm going to give you a little more practical perspective. You heard the formulas he talked of on the pumping speed of creating the vacuum. I'm going to actually give you some tips, tricks and traps relating to semiconductors, and the process of creating ultra high vacuum. So you heard him. What is a roughing vacuum? Till what range will a roughing vacuum be? 10 to power minus 3. Who said it? Sushantji. Okay. Where does the high vacuum start? Okay. To what range does high vacuum play? And okay. So Devrajji, I will give. You already collected so many. So there you are. Okay. And then you have ultra high vacuum. Okay, you are now in the era of 10 to power minus 7, 10 to power minus 10. Okay, how do you actually reach that? You have to reach that in semiconductors, and then you have to understand what are the economics relating to it. You have to understand the concepts of leakage detection. I can almost skip it. Sir has already talked a little about it, and I want to talk a little about vacuum system design, because actually, ultimately, engineering is not just the technical part of it. Engineering is when you can design a system and see that it is working as per your requirement. Both things hold. There is theory and there is practical. We'll talk about practicals first. In case of vacuum technology, there are components of the vacuum technology systems like O-rings, seals and gaskets. These are simply components that will fit on the pipes, hold that seal together. Okay, these are gaskets are something like this. Between two piping system, it's something which will enable the the contacts between two different parts of the piping system. Imagine a situation if there is something that is a leak from here. It can compromise your entire vacuum creation process. Therefore, if you're going to the UHV ultra high vacuums, you actually need to make sure that these are appropriate components. You will not normally use just normal polymer seals that are available in the market. These seals will degas. They would have some atmospheric gases absorbed in it. If you actually use them in your vacuum system, they will outgas, and therefore your vacuum will never be perfect. Especially if you're going to UHVs, you have to make sure that you're using the right O-rings, seals and gaskets. So this is tip 1. Tip 2 is you can play with between repair and preventive maintenance, but really the right thing is to have a preventive maintenance, because then you actually go for a predictable and more efficient execution of your process of creating the ultra high vacuums. There is always this situation where you can have different type of greases to do the sealing of your mechanical points. Would you use a hydrocarbon grease? Would you use a silicone grease? Well, let me tell you, there have been instances when people thought that they can use the normal hydrocarbon grease in their vacuum pumps for semiconductors, and it can be a disaster. Simply because the hydrocarbon grease will be based from the hydrocarbon from mineral oils. Okay, they can degas. They can reduce the life of your O-rings and seals. Okay, it will, for saving that little price, you will pay a very heavy cost. Sir has talked of the process of time to nothing as a key thing. So this is one of the fundamental things. How fast can you reach vacuum? Okay, in a semiconductor system, you know the cost of the semiconductor projects. Tata is putting up the project for 91,000 crore with 91,000 crore subsidy. Okay, it will have all these equipments. Each of the tools will cost you anything like 20 crores. Just one part of the tool will cost you 20 crores to 50 crores. Now imagine a situation, to make it fully operational, you need to take it to ultra high vacuum. If you have a downtime on that, what is the cost of that particular tool? And forget that. If it is down, other parts of the system are compromised, other part of the value chain is compromised. So really speaking, in semiconductor industry, you don't cut corners. You have very clear specifications given by the technology providers. You just take that. I mean, what I'm saying is what any of the applied people would be saying. I'm sure if the lamp people are here somewhere, they would strongly echo that. You just don't compromise on the specifications that materials that have been given in. Silicon VP grease is one of the things that is used for high vacuum, but then you have to take care and take whatever is the grease specified by your technology provider for your recipe for that particular condition. Same thing applies to vacuum pump oils. Wherever you're using vacuum pumps which have vacuum pump oils in it, please don't replace it with a simple hydraulic pump. Same thing applies. There can be degassing, there can be a compromise on it. I have seen with a customer a chamber where somebody actually used a conventional material out there. The customer came back that, look, I'm having some streaks in the chamber, which when my service engineers came and they looked at it, they said, oh, this is a black grass effect. I don't know if you know of it, but it's actually, there were streaks of grease flowing back into the chamber because there was a wrong sealant that was used for it. The repercussion, you have a 5 crore chamber and you are actually going to take it out of the process for some time. It's got to go for decontamination, cleaning, that will never be new. So there is a huge cost. If you want to change anything, there is a lab for it. A lab is a place for it, not the production floor. Okay, so this is again a key message back. You use evaporation boats in your processes a lot. What is an evaporation boat? Typically, there will be some ceramic component which is used, in which you will put different metals, etc. Your objective is to evaporate that in your sputter process or whatever other process, and you would actually clamp it to the heat source and the electric source using a copper clamp, and that clamp is never perfect, so there can be sparking and reduces the life of the evaporation boat, which is also a cost. So you will typically end up using a graphite foil, which is a very strong conductor, which can be used to intermediate between the evaporation boat and the clamp. What you must do is, there are crinkled graphite tapes available low cost in the marketplace. There are plain graphite tapes, high purity graphite tapes that are available. This will appear in a 100-meter roll, 50-meter roll. This will be just a small length, but this is actually the thing that you have to use. If you try and use the crinkled graphite tape, it will never get a perfect clamp, and it is going to be a price that you will pay for your life of your evaporation boat. So the key messages is, use good quality grade oils and grease, no R&D on the shop floor, prepare vacuum chamber, proper vacuum chamber cleaning is required, good quality diffusion pump oils whenever you use it, timely change your vacuum pump oils. The new oil will likely have a color which is like a golden color here, but as it oxidizes, it will become darker and darker, almost become a sludge. In most situations, your technology provider, your premise might have a rule that change it after so many hours of usage. Just follow it. Don't try and cut corners. This is a photo where I have a silicon grease, and of course the brown one is the hydrocarbon grease. Moistures and gases can be trapped on the surface of vacuum chambers. So you end up following some process in real life to again improve the time to vacuum. One of them is baking. You actually, if you're going to UHVs, you have to bake your vacuum chamber, and while this talks of a few hours to bake a vacuum chambers, there are times when you may actually have to do it for days. Okay, depending on the process that you're going for, you must actually be you must follow the rigor of the process that is defined. There is no shortcut to it. Okay, a proper baking can reduce your ultra high vacuum time to ultra high vacuum dramatically. So this is a key part of it. You have to moisture is a key issue that can be faced in your journey in creating a vacuum. So there are a lot of techniques for it. Of course, you can use dehumidifiers, air conditioners. Sometimes you use inert gases like argon, helium to do a vacuum purging of the chamber, so it carries away some of the moisture. These are some of the techniques. Again, that's my 14th tip back to you. Sometimes what happens is there are virtual leaks. That means a big chamber, some part of it is at a high vacuum, another part of it is still having some gas in it, or some something is still getting outgas from some part of it. So you have to actually look at your chamber structure, and you have to actually position your pumps to evacuate as efficiently as you can. So this is tip 15. The leak detection has already been covered by Professor Rao. You have simple things. You will do a physical leak detection. Do you hear a noise, a sound which is indicating a leak? Do you actually do a trace gas which is sucked into the system, and then you start actually Pirani gas will actually, it's very sensitive to the compositions, it will actually be able to tell you there is a change in the composition, there is a leak. Okay, if you actually go for a helium gas as was shared, you start with spraying it at the top of your vacuum chamber or of the system, and then you start coming down. Wherever the leak is there, it will suck in the helium, and you can detect it in your output. The spectrometers will actually detect helium in the output. So that is the process for a helium gas leak. Move from top to bottom in your process for selecting the for isolating a helium for isolating a helium leak. Finally, the last one that I want to share is the design. Not many people realize it, but you can design a vacuum system. Okay, you will actually have a series of pumps in your UHV implementation. There will be a roughing pump, there will be additional pumps which will actually work in conjunction to deliver that ultra high vacuum, and you need a tool for it. There is a tool called Vactran available. It's a software. Okay, so design guys are not off the mark, they do find their place. I'm just trying to tell you there are different design tools. So Vactran will actually be able to look at, you can actually model the system, the pumps, the conductance elements like pipes and elbows. You can actually model it, and you can therefore create an estimation of what is the likely behavior of that system. You can calculate the pump down time with and without gas loads, model the different types of conductance elements, calculate the rate of pressure rise, model surface outgassing, permissions, leaks, okay, create graphs, create models which you can say, am I actually achieving my ultra high vacuum or vacuum in the designated time? What could be going wrong? Okay, it's an indicator if you are too much off the indicated time. What does Vactran do? You will have the software. You can have up to 6 different types of pumps, select different conductances, different types of gas loads, different type of outgassing parameters. You can actually model and create your reports. What it cannot do, it is not going to give you safety related calculations or give you CAD-like renderings, calculate back pressure effects. No, it is primarily to give you an indication of the vacuum system that you are designing. That's about it. There are other tools available. There is something called FitVac. Okay, but by and large, a lot of companies use Vactran. We use Vactran. Okay, and that's been an industry standard for almost half a century. So vacuum technologies is a key role in semiconductor industry. It is one of the subjects which has been put in your AICT curriculum. You get a good coverage of the theory relating to vacuum technology for semiconductors in the various units that have been planned for it. You can actually do a lot of things to deliver a quality vacuum, and that is what this program is priming you to look at. I guess with that I complete my session. If there are any questions, I can take that up. Otherwise, we'll break for tea. Oh, we must have Kalpana ji to do the honors. Nobody will come back.
Hi, can you all hear me? Yeah, thank you so much for joining us in this program. I think a lot of you have traveled from out of the city as well to be here. So I want to take an opportunity to thank all of you for making this program successful. This is a series of tutorial programs that we are doing to enable people to understand what's happening in the semiconductor industry and what are the skills required to be a part of this industry. So I also will like to take this opportunity to thank all the people who've been involved in making this event happen. First and foremost, Dr. Ashwini, he is the force behind this, and I think all of you are really lucky to have gotten an opportunity to learn from an industry veteran like him. I think kudos to his energy and enthusiasm that after retirement he's taken such a huge task on himself to help the country build the required skills for this industry. So thank you so much, Ashwiniji, for doing this for us. And I want to thank all our partners from CeNSE, Sandeep Saxena ji, I don't know where is Rashika, and Prem Kumar ji for really kind of making this happen. We've been talking for I think more than 3-4 months now for this day to happen. So we are here today, and hopefully all of you are taking back something from these 2 days. I also want to thank all our speakers who've come down to make this 2-day workshop happen. Some of the students, I think, were a little disappointed that we could not give them the facility tour, and we had to restrict the number of people to whom we gave the facility tour. So I want to kind of apologize to the ones who could not get the facility tour. The reason for that is that these are areas where somebody who's qualified and trained and who has passed a test can only accompany the visitors and take them around. So we had limited staff today because we are also having another training program. Every Friday between 3 to 5, we host other academic institutions and come and have lab tours. So you can write to us and we can facilitate that for your academic institution, and we can do that. Today we had to restrict the number to about 40 people, mostly our faculty members and the industry partners. We open the facility tour for our students also. So every Friday between 3 to 5 we do that. So please write a formal mail to us, and if you can tell you are from which institution and how many of you want to visit, we will make that happen. December, the last 2 weeks, the facility is shut down for annual maintenance, so no more tours in December. But from January onwards, we will definitely enable this. In January, we are also having a huge road show where all the institutions where there are these similar kind of setup. I mean, we are the largest academic fab in the country, but then there are other institutions also who have clean room facilities. So 7 institutions are coming together to IISc, and we will be showcasing all the capabilities across these institutions. So if you want to be part of it, you want to get an invitation, please drop us an email and we'll make sure your institution gets an invite to participate at an event. I'll give you my email credentials obviously. I also want to thank all our knowledge partners, SEMI, SID, and ESCI, and our sponsors, CeNSE Semicon and Applied Materials. It's been a great event. We regularly conduct training programs, so please follow the CeNSE. So that is Center for Nanoscience and Engineering. Please follow our department on LinkedIn and on our webpage. We are constantly doing a lot of training programs. Starting from Monday, 9th December, a winter school is starting. It's an online winter school for 2 weeks for semiconductor technology. We do a summer school as well. So because it's online, we don't restrict the number of people. And most of the time, these are free. These are sponsored under government schemes. We also run a program which is funded by the Ministry of Tribal Affairs, specifically for students from the tribal background. So this is a 2-level program where the first program is a online 3-day kind of a program, and subsequently there is a classroom and a lab kind of a program where you come to IISc and you spend a week in IISc, both the classroom as well as you get to see all the lab facilities. So that's another program that we run. Again, most of these programs either are extremely subsidized in terms of the fee or they are free. So please follow us on our social media pages. we will update. And for faculty also, we do faculty development programs. Even those are published there. And you can, the faculty can also kind of, and all these programs are available both to faculty as well as students. So you can enroll into those courses. We will be publishing a calendar going forward on our website because we have been getting a lot of these requests. So from January onwards, we will have a calendar on what are all the trainings scheduled for the year. So you can plan to attend any of those programs. And for the facility tour, please write to us. We will make it happen. Yeah, in whatever way we can accommodate, we will plan for it ahead. Even our facilities needs a little bit of a notice if it's a bigger group. So we will plan it. Actually, we were totally surprised by the kind of huge response we got to this. 700 registration and 200 of you actually came to attend the workshop was a big number. So we are very happy, and we definitely want to enable this excitement and continue to offer these kind of seminars and conferences. So please follow us, and our email contact. So my brief introduction. I manage the industry academia relations for the Center for Nanoscience and Engineering. So we provide a single window interaction for all our industry partners. And I also manage an incubation program for startups in the nanoscience and semiconductor space. We have 12 startups that are right now incubated with us across various areas. So if there are some of you who want to be entrepreneurs in this space, who have some ideas, please drop us an email, and we can talk more and see how to nurture your entrepreneurship ideas. A big thanks to the Government of Karnataka, who is our key sponsor and promoter. Government of Karnataka is also funding the incubation program here in CeNSE. So happy to talk to any one of you who wants to pursue an entrepreneurial journey and wants to incubate with us. Happy to share details of that. So I'll just leave my email. It's industry.censc, industry.censce@iisc.ac.in, and my name is Kalpana. I lead the industry office. So thank you once again to all the participants and everybody who made this event happen. Thank you so much, and I think now we can break for tea.
Madam, you did. So special thanks to you. Oh, you were there in the trenches right from day one. Sandeep, you, Rashika, but you were there as a key anchor for us. And I must thank ISC. Finally, we got this venue because of you. Really appreciate it. All the people who worked to make it happen, Sandeep, Prem, Rashika, I don't see Rashika. Okay, I'm telling you, all this team made it happen. Professor Rao, all the subject matter experts, they made it happen. So thanks everybody, all of you for coming in and giving us that impetus for this program. Do well.
So there is a request that we should have a group photograph with everyone. So I checked up with my photographer. He said he will try his best to capture maximum number of faces, but definitely it will show the strength that okay, so many people have participated in this
Why? You must have taken photograph
yes.
even otherwise of the
Yeah, otherwise he has taken the photograph, but he wants to have one group with Professor Rao, with Dr. Ashwani Agarwal, everyone here. So may I request everyone to please come
Let's
here.
see.
Maybe all the girls can be in the front row and the boys can be over here, so that we will be able to cover maximum.
Photographer has to tell us.
No, let's just take the photo.
Let's just take one. Nobody can take it from the back side.
It's not to see the faces, it's just for the number.
It's like the number and the movement power. So many people will come. So
But Kalpana ji.
to see like so many girls joining this African industry.
Yes.
Yeah.
Yes.
Excuse me, all the faculties just 2 minutes stay back, and students and I mean others can leave. This is the faculty. The tea is with there outside. All the faculties just for
Thank you.
2 minutes.
Cheers. My pleasure. I appreciate you saying that. I'm really grateful that it worked well for you. Hi.
Yeah, you can sit in
Really
this place.
appreciate that. I really
The front
like
row,
your
please.
saying that to me. Makes me feel that I must really back you up wherever I can. Thanks.
Now, sir.
Okay, my email I can give you, or you can take my number.
No, students have left.
My email is number you want? Anything, sir. Whichever is. Take the number 9910 555 970. Okay. Yes, sir. In future, if you need anything, we'll contact. Please do. Not an issue. Cheers. God bless you. Thank you, Sanjeev ji. Rakesh ji, wonderful. Do you want to take some more chocolates?
I think I want the most of them.
Yes.
बैग के पीछे मत गिर जाना हाँ शेक हो गया पूरी तरह दूसरा एक और है हाँ
अच्छा ये ठीक है एक कॉपी मुझे भी भेज दीजिएगा
पक्का भेजता हूँ सर आपका नंबर तो दे दीजिए
9910 कार्ड देता हूँ
ना दे दीजिए
इसमें ईमेल गलत है
मेरा
But-
तो वही
Okay,
हाल है,
but-
first of all, thank you very much for taking
card
out
is-
time and then
number
giving
is
2 days,
दोनों
to
numbers
this
same है,
workshop.
but use the
We
mobile
really
for
appreciate.
WhatsApp.
From ELSINA side, we are working with various initiatives on the semiconductor space. Also, we have got a vertical where we engage industry with the academia, right? In that process,
See you, Sanjeev ji.
I wanted
See
to
you,
just
Bharti ma'am.
connect with the academia,
was it useful?
with the faculty members, right? So that the universities which you represent, right? We can connect with ELSINA and maybe we can make you as our corporate members, so that in future wherever we are organizing such events,
Oh,
right?
Bharti, we are
can
honored to have you here.
invite you for that. We can
Just
also
tell,
get the industry
just tell
visit your
PVT,
university, visit your
your
facilities,
because,
interact
I
with
want
the
to
students
see
over
that,
there, and also explore the possibility of identifying the right curriculum and the courses which are going to help them. And there can be a commit from the industry side that yes, at the end of the session they will absorb 25, 50, 100 students from your faculty. So we also got one very good suggestion from our sister association IISc, Electronic Sector Skill Council of India, which I discussed with Dr. Hegde from Christ University, and it is that probably we will be discussing with Dr. Ashwani Agarwal also on this, that something similar can be organized only for the faculty members and the industry, and it will become like a 2 days residential program, right? Christ has come forward to support this particular event in Bangalore, so we will identify the universities preferably across the country and ask them to give 1 or 2 faculty members from the respective departments of electronics or semiconductor space, and then we will have such courses for a 2-day event. And then so that for the faculty it will be more of a train the trainer concept, and the industry, it will be the people who are there on the ground, who are there on the line working there, so it will be eye opener for them also in terms of what are the technologies which are available. We will also be getting the companies who are into the semiconductor equipments to come and make presentation at that point of time. So just be connected with us with ELSINA. My colleague is there, Prem and Rashika, so they will connect with you, have the cards, and then we will be sending you all the details by next week. Thank you very much. Thanks a lot. So please have tea outside. Thank you.